In this problem, we're supposed to analyze the graph of the function, and it'll take us through the steps in the online homework, but I just put up the steps that we learned in class, the steps to graphing rational functions. So we're going to start down here at the bottom, and that's what I've labeled Part A, find the domain. So we want to exclude the values where our vertical asymptotes are. So to find the domain, we want to look for those illegal situations. So we look at the bottom of the denominator and say, well, x plus 7 can't equal 0, so let's find out where it equals 0. That's at x equals negative 7. And that's where our vertical asymptote is going to be 1, 2, 3, 4, 5, 6, 7. Oops, let's get a different color here. So wherever our excluded values from the domain are, that's where our vertical asymptote is going to be. And we would write our domain as set of all x's such that x can be anything, but x can't be negative 7. And we draw a vertical asymptote. Part B, so we got that checked off. Part B is find the y-intercepts if there is one. So to find the y-intercepts, we just plug a 0 in all the x spots. So once I do that, I get negative 16/7. So that's going to be our y-intercept. So let's plot that on here. That's a little bit bigger than 2. So this is a rough sketch. We'll just plot that right there. So we got the second box checked off. Next one is find the x-intercepts if there are any by setting the numerator of the fraction equal to 0 and solve. So I took the numerator this time, set it equal to 0. If it will factor, that's what you want to try to do. If it won't factor, you have to use the quadratic formula. But this one will factor, so set it equal to 0, we get x equals 16 and negative 1. That's going to be our two x-intercepts. Negative 1 and positive 16. Part D says test for symmetry by putting negative x in for x. So I did that to see if I would get the opposite of what I started with, but I didn't, so it's not going to be symmetrical around the y-axis. Next one is find horizontal or oblique asymptotes by comparing degrees. So if you look at the top degree, it's a degree 2, and the bottom degree is degree 1. We learned if the top is 1 greater than the bottom, we're going to have to do long division. So let's start that here. So we put the top inside the division sign and the denominator went on the outside. Start with this x and say, what can I times x by to get x squared? And you'd say x. Then we multiply that through. X times x is x squared. We multiply it by the 7 as well. X times 7x is 7x. Or x times 7 is 7x. Then we subtract everything. So these cancel. Negative 15x minus 7x is negative 22x. Bring down the negative 16. Now we only have to go one more step. So what could we times x by to get negative 22x? And that would be negative 22. So we could multiply this back through to get negative 22x. 22 times 7, that's for 154, negative 154. We don't actually have to go any further from there. We can stop there once we get these first two terms, because that's going to be the equation of our oblique asymptote. So y equals x minus 22. And we're going to graph that here. I guess I need to go a little further down on my y-axis. This is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I had to go a little bit further because this is the equation of the asymptote. So if I use my y equals mx plus b form, then my y-intercept is going to be at negative 22, and my slope is going to be 1. So it's going to be, this is just rough sketch, but this is going to be my oblique asymptote. It's a diagonal line going like that. So then we're going to find some points on either side of each vertical asymptote. We already have some on this side. We would want to find some on the other side to plug into the function. So like this was at negative 7, so maybe I want to pick like negative 10. Plug a negative 10 into our function. I'll call this part F. So we plug negative 10 minus 15 times negative 10 minus 16 all over negative 10 plus 7. So here we'd actually get negative 78. So this tells us if we were at negative 10 here, 7, 8, 9, 10, we're going to be way down here at negative 78. So when we're trying to put it all together, the last step is to connect all the points and head towards the asymptotes. My graph is a little bit, it's going to be more zoomed out than what I have here. So let me plot here what the actual function looked like for your answer. This is already in zoomed out form. We picked this one because we have the points up here that would make the parabola there, and then we know that the point's way down there.